with the transition metals have been kind of introduced to you with complex ion formation. And this is kind of where I want to start and kind of take a step back and think a little bit differently about how we're going to be analyzing these particular coordination complexes. So the next unit that we're going to analyze is transition metals and coordination complexes. And these two go hand in hand because most coordination complexes have a transition metal at their center. The first thing, or our first experience with these transition metals, are various complex ions. So if you have Ni, NH3, 2+, and you compare it to cobalt, NH3, 2+, and we also compare that to zinc, NH3, 6, 2+. And sorry, these have 6 ligands on each one. So we have these complex ions. We've seen them before. And we experienced them in our qualitative analysis scheme. We went over some calculations that discussed these complex ions, and a couple observations can be made. The first one is that this nickel complex is blue. The second observation we can make is that this cobalt complex is pink. So from a first approximation, you can maybe come up with a hypothesis of, all right, all these transition metals, when we coordinate ammonia to them, they're going to give us a nice color solution. But if we coordinate ammonia to zinc, we're going to get a clear or a colorless solution. But the one thing that really fascinated chemists about transition metal chemistry way back in the day was the color that these solutions and that these solids exhibit. So the question is, why do these complexes exhibit the colors that they do? And it's kind of going to come down to two main things that I definitely want you to keep in the back of your mind as we progress through this unit. The first thing that we're going to look at is the d electron count. If you look on the periodic table, all of the transition metals come in the middle block. Sometimes we call the D block. So we're going to have to keep in mind the electron configuration of all these transition metals because it's going to have a big impact on the color. The other thing that we have to look at is the energy levels in the complex ions. So we're going to kind of talk about what those energy levels are, and we then need to use some type of tool or some type of instrument to analyze these electronic excitations. Because essentially what gives these compounds their color is I can take a particular complex ion and we would put it in its ground state, which would be its lowest energy configuration. If an electron is excited from one energy level to a higher energy level to form what we call an excited state, if it's in the right region of the electromagnetic spectrum, we can observe that color with our eyes. So this kind of paints the picture of what we're going to be looking at.